Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 10th May 2023. The problem statement for today is total cuts. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Here it is said, you are given an array A of n integers and an integer k. Your task is to find the total number of cuts that you can make such that for each cut, these two conditions are satisfied. The first condition is that a cut divides an array into two equal or unequal parts. That should be non-zero. And the second condition is that sum of the largest element in the left part and the smallest element in the right part is greater than or equal to k. Okay, so while dividing this array into two parts, we need to take care of these two conditions. Each part should contain at least one element. That means it should not be zero, that is non-zero. And second condition is that the sum of the largest element from the left part and the smallest element from the right part, when we add these two, that should be greater than or equal to k. How many such counts are there, that we need to count and return it. I hope the problem statement is clear. So actually, the problem statement requires us to find total number of cuts that divide an array into two parts such that the sum of the largest element in the left part and the smallest element in the right part is greater than or equal to k. Let's go through the given examples to understand it in a better way. So here in input it is saying that in first example in input it is that n is equal to 3 and k is equal to 3. So n is equal to 3 means the three elements are there in this array. So an array A contained element like 1, 2 and 3. So here the output is 2. So how the output is 2? Now we are dividing this array into two ways such that both the conditions are satisfied. So the first part, when dividing this array, when we are dividing it for the first time, so in the left array we are just keeping 1 and on the right part we are keeping 2 and 3. Okay, so we take the largest element from the left part. Here it is only one element is there, so that's why 1 is taken, and smallest element from the right part, two elements are there, 2 is the smallest, so we have taken 2. When we add these two, so that satisfies the condition, that is greater than or equal to 3. So this was the first partition or the first part, and that means the way we are dividing the array. So this was the first division. We can also divide the array in this format. That means left part contains 1 and 2 and right part contains 3. So maximum element from the left part, that is 2, minimum element from the right part, that is 3, since only one element is there. So when we add these two, the sum is 5, which is greater than or equal to 3. So this condition is satisfied. That's why we are getting these two divisions. That's why we have got the output as 2. When we look at the second example, here n is equal to 5 and k is equal to 5. And array A contained element like 1, 2, 3, 4 and 5. So we are dividing it into three such divisions that satisfies the condition. So in the first division, the left part contained 1 and 2, right part contained 3, 4, 5. So maximum from the left, minimum from the right, that is 2 and 3, that is greater than or equal to 5, condition satisfied. In the second division, we are dividing in this way. So largest from the left, smallest from the right, that is 3 plus 4, that is 7, 7 greater than or equal to 5. Then we are dividing in this way. So 1, 2, 3, 4 and here right part only contains 5. So here maximum from this, minimum from this, it is 4 plus 5, that is 9, 9 greater than or equal to 5. So we are getting 3 divisions. So the output is 3. Okay, so I hope both the problem statement and the given examples are clear. So for solving this problem, the approach which we will be using is using two arrays to store the minimum element in the left part, to store the maximum element from the left part and minimum element in the right part of each cut. So we will be using two arrays that will store maximum element from the left part and minimum element from the right part for each cut. That means each cut or division or each partition. Okay, so this approach we will be following. Then what we will do, we will pre-compute the maximum element in the left part for each cut we can use an array called max left to store the maximum element in the left part of for each cut. Similarly, we will also pre-compute the minimum element in the right part for each cut. We can use another array that we can call as min right to store the minimum element in the right part for each cut. Okay, let's understand it exactly how we will be doing this. So first I have taken this example, the second example only. So here n is equal to 5, k is equal to 5, and array contains element 1 to 5. So what we are doing, so the way we will be dividing it. Okay, so we will be storing the maximum element from each part, from each cut in the max left, and the minimum element from the right part or the right cut, that will be in the min right array. Okay, so if you are dividing this array, that means left part contains only 1, right part contains 2, 3, 4 and 5. Okay, 2, 3, 4 and 5. So what we are doing, we are storing this one, the maximum element from this one, that is here, that is 1 here, and minimum element from the right, that we are storing at this index position. We are storing it this way because we will be while checking the condition, we will be checking the first value from this one and next value from the min right one, so that we can add it and we can check for the given condition. Similarly, if you are dividing if you are dividing it in such a way, the first, that means the left part contains 1 and 2 and right part contains 3, 4 and 5. So the maximum on the left part, that is 2, minimum among the right part, that is 3. So that is 3 here. Similarly for 3, 4 and 5, the maximum from the left part will be 3, minimum from the right part, that will be 4, and here for maximum will be from maximum from the left part when we are dividing in these two. Left part contains 1, 2, 3, 4 and right part contains only 5. So maximum from the left part, that is 4, and minimum from the right part, that is 5. Okay, once we are getting this, then we add the element from max left to the corresponding element from the right max, from the min right. Okay, so here first we will check this one. Actually, let me just give an indentation here so that it becomes aligned. So we will be checking first with this one. We will be checking I from that means element I from max left and I plus 1 from min right. So first we will add 1 and 3. 1 and 3 we will check. Is this greater than or equal to 5? So 1 plus 2, that will give 3. 3 is not greater than or equal to 5. So count will be 0. Now we will look 2 and 3. That means index 1 from left from max left and index 2 from min right. So now it will add 2 and 3, this diagonally 2 and 3. So it will check whether this addition of these 2 and 3, that will give 5, if whether this is greater than or equal to k. So yeah, 5 is greater than or equal to 5, so count will be incremented by 1. Similarly for 3 and 4, we get the sum as 7. Here also this condition satisfies, it is greater than 5, so count will be incremented as 2. For the last one, we are adding 4 and 5. So here the summation is 9. So 9 is again greater than or equal to k, that is 5. So we are getting the count as 3. That means first pair is 2, 3, then 3 is 4 and 4, 5. Okay. Why we have kept this one 0? That means we are keeping it for that condition, that we are dividing it in a such part that each part should not contain any element as 0. That means it should not be empty. Okay, so at least if you are having 1 to 5 here, so at least in the left part we can take only up to 1 to 4 elements. We cannot take all 5. If you take all 5 in left part, the right part will have 0 elements. That's why we have taken only up to 4. Similarly, on the right part, we are leaving the first one. Okay, and we are taking the number of parts from the for the min right array, that is equal to maximum up to 4. So if you are starting from the right, then the maximum element is here. It is the smallest element is 5. Similarly, when we are having 4 and 5, the minimum element is 4. when we having 3, 4 and 5, the minimum element is 3. Similarly, among 2, 3, 4, 5, the minimum element is 2. So we cannot take even one here. Even if we are taking this, then the left part will not have any element. So that's why we are not taking that one. That's why whatever we have initialized as 0, that is only there. It is not replaced with any other value. Okay, so that's why we have got the output here as 3. But if you look at the second example, that means I've taken some more examples to explain it in a better way, where n is equal to 5, k is still 5. But if actually it should be opposite. If it is 5, 4, 3, 2, 1. Okay, so suppose we have array elements in this form, that is 5, 4, 3, 2, 1. So whatever divisions we take from the left, for the left, always we get the maximum element as 5 only. If you take 5, then maximum element is 5. If you take 5 and 4, maximum element is 5. If you take 5, 3, 4, 5, 4, 3, the maximum element is 5. Similarly, so whatever element we take, whatever partition we do, the maximum element from the left part will always be 5. So that's why 5 is there in all these 4 places. Similarly, when we are looking for the min right, so whatever division we do for the right one, starting from the right, whatever division we take, the minimum element will always be 1 only. If we have only 1 as the right part, then also it is 1. If we have 2 and 1 as the right part, then also it is 1. Similarly, if we have these 3 elements, then also minimum is 1. 4 to 1, then also minimum is 1. Okay, so now here also we will do addition that way only. So here we see, now we take ith element from the max left and I plus 1 element from the min right. When we add these two, it will be 6 greater than or equal to 5, count 1. This also we will add 6 greater than 5, count 2. This also we will add, it will also give 6 greater than 5, count 3. 5 plus 1 again 6, it is also greater than 5, so count 4. That's why the output here is 4. Here another example I have taken where it is a mix of the numbers, that is neither in ascending order or not in descending order. So here n and k, that is still the same. In array A, I have taken this input, that is 3, 5, 4, 1, 2. Okay, so again if you try dividing it into left and right part, so if you are taking for only 3, then the maximum is 3. Apart from that, if you are taking 5, the maximum is 5. Apart from that, even if we increase the number of elements in the left partition, we will always get the maximum element as 5 only. So that's why it is 5. Similarly, when we are trying to find for the min right, so the minimum element from the right, if we have only one element there, so that is the output here. So that is the minimum element for the right, from the right part. If we have right part as 1, 2, minimum element is 1. Right part as 4, 1, 2, the minimum element is 1. Similarly, even if we take 5, 4, 1, 2, the minimum element is 1. Again, we are not taking all elements in the right part, because again it is saying in the, it was said in the problem statement, a cut divides an array into 2 equal parts, that is non-zero. So it should not be that any part is having 0 elements or it is empty set. Okay, so here also if you try adding in the similar way, 3 plus 1, that is 4, is it greater than or equal to 5? No, we will leave this, count 0. 5 plus 1, it is 6, greater than or equal to 5, count 1. 5 plus 1, 6, greater than or equal to 5, count 2. 5 plus 2, 7, greater than or equal to 5, condition true, count 3. That's why output is 3. So I hope the logic is completely clear, and the approach and the way we will be solving this problem. So I hope that is clear to you. So with this approach only, I have prepared the solution in both Java and C++. First I am taking Java solution. So let me move to Java editor. So here also I've given comments so that it becomes easy in understanding. So what we are doing, first we initialize count as equal to 0. Okay, then we are pre-computing the maximum element in the left part for each cut. So what we are doing for that, we are initializing we are creating an max left integer array to store the maximum element in the left part for each cut. So that will be stored in this. So initially we are storing max left as a of 0. Whatever the element is there in a of 0, that will be stored in max left of 0. For rest of the element, we check whatever is the maximum element, so that we are storing in this one, so that we are storing in max of I. Okay, so how exactly we are doing that? So as I have explained in various examples, whatever is the maximum element from the left part, that only we are taking. So initially when we are storing a of 0 in max left of 0, so first element contained 3, next element contained 5. So we are comparing whether 3 is greater or the 5 is greater. So 5 is greater, so that's why 5 is coming here. Okay, for the next one we are checking whatever is stored in the previous value, if that is greater or 4 is greater. So this itself is greater, that's why we are taking 5 again. Again we are checking whether this 1 is greater or 5 is greater. So yeah, this 5 is greater, so again we are getting 5 is greater, that's why we are storing 5. Okay, so we are just trying to store the maximum element in each cut of the left part, that we are storing in max left, all the possible cuts in the left part. Similarly, we are pre-computing the minimum element in the right part for each cut. So again for that, we are creating an integer array that is called min right. So for min right of last element at last index, we are storing a of n of I. Okay, it's a similar way here. First we are populating that 2 here. Coming from the right side, we are checking, we are adding 2 here. Then from the next one, we check whether one among these two, which one is smaller. So we are getting 1 is smaller. That means again it is checking from this and this value, which one is smaller. We are getting this current value is smaller, so that is coming here is 1. From this one we are going to check this is smaller or the previous value from the min right array, which one is smaller. We are getting 1 is smaller, that's why we are populating. So for this right min array, we are coming from the right side. Okay, so we are first populating a of n of I, then we are iterating the loop, and it will continue. We are starting from n minus 2, and it will continue till I is greater than or equal to 0. We are not taking I is equal to 0 again, because we are leaving at least one element for the left part. So this way we are calculating max left and min right array. Now after these two arrays are populated, then we are again iterating through the complete size there. We are actually iterating till n minus 1. The reason is that we are checking the left, the ith index element from the left max, from the max left, and I plus first element from min right, and that we are adding and we are checking. If it is greater than or equal to k, then we are increasing the count, and finally we return the count. Okay, so that's it in the coding part. I hope this solution is pretty clear. So let me try compiling this code. So here we can see we have got correct output for this given input. Let me try submitting this solution. So here we can see we have got all the test cases covered. So this problem is solved successfully with this code, whatever I have written in Java. So when we talk about the time complexity of the solution, it is in the order of big O of n. Since we need to loop through the array twice to compute max left and min right arrays, and then one more to count the valid cuts. Therefore, the solution should be efficient and should pass all the test cases within the time limit. Okay, so this was a Java solution. Even I have prepared C++ solution for the same problem. Let me move to C++ editor. Let me copy that code here. The logic is completely same. Only some syntactical difference, the way we initialize the array and all those things, that is there. Here also we have the count is equal to 0 as initialized ones. Then we are creating two array, max left and min right. We are populating these two array. Again checking the max for the checking the maximum among two elements for the max left and minimum element for the min right. Once we get these two array, then we are checking max left of I and min right of I plus 1. When we add these two, if it is greater than or equal to k, then we increase the count and we return the count at the last once this iteration is done. Okay, so here the logic is completely same. Let me try compiling this code. So here we can see we have got correct output even for this. Let me try submitting this solution. See, even with this code in C++, we have got all the test cases covered. So this problem has been solved successfully in both C++ and Java language. Okay, so I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video and please subscribe to the channel for more upcoming videos. Thank you for watching.